A scientist kneels in the dry gravel of a Yellowstone creek, holding a ruler against a willow shrub. The plant is barely knee-high. It sits inside a wire fence built years ago to keep every elk out, and still it will not grow. All around him, the world believes this valley was already saved. A video says so. 40 million people watched wolves come home and, supposedly, bend these rivers back into shape. So he stares at the ruler and at the stunted willow that no elk has even touched, and he asks the question nobody wanted asked. Why? To understand why that willow refused to grow, you have to go back to a winter that felt like a miracle. In January of 1995, 14 gray wolves arrived in Yellowstone inside wooden shipping crates hauled down from Canada. The next year, 17 more followed. 31 animals total. That is it. 31 wolves dropped into a landscape the size of a small country, a place that had not heard a wolf howl in roughly 70 years. The last ones had been shot and poisoned out by the late 1920s, back when a good predator was a dead predator. And then something happened that looked for all the world like magic. The elk changed. For decades, they had stood around in the open valleys of the northern range, fat and unbothered, stripping the young willows and aspens down to nubs. Now, with wolves hunting again, the elk got nervous. They stopped lingering on the exposed riverbanks where a pack could corner them. They moved more, ate on the run, kept to cover. Scientists gave it a name that stuck: the landscape of fear. And where the elk stopped loitering, the story goes, the willows shot up. The aspens returned, songbirds came back to the new branches, beavers returned to the ponds, and the rivers, freed from erosion by all that new streamside growth, supposedly narrowed, steadied, and settled into cleaner, straighter channels. That is the version you have heard. It became one of the most famous nature stories on Earth. A short film called How Wolves Change Rivers has been watched more than 40 million times. It is beautiful. It is tidy. It is the kind of story that makes you believe the whole broken world could be fixed if we just put the right animal back. There is only one problem. Out in the field, kneeling in the gravel with a ruler, the scientists checking the actual plants kept finding willows that had not read the script. Meet the people who broke the story open. In 2001, a team of ecologists from Colorado State University, led by David Cooper and Tom Hobbs, along with a doctoral student named Kristen Marshall, went into the northern range to do something that sounds almost boring. They wanted to prove the beautiful story with hard numbers. If fewer elk meant taller willows, they could show it, cleanly, with fences and measurements. So they built exclosures, wire fences around patches of willow designed to keep every last elk out. Inside those fences, no elk would ever take a bite. If browsing was the thing holding the willows down, then inside the fence, the willows should explode. They waited. Years passed, and the willows barely moved. This was not a quick guess or a single unlucky plot. The team worked at more than 20 sites across the northern range, and they kept at it for the better part of 2 decades. Year after year, they came back with their rulers and their notebooks, measured the same protected willows, and watched them refuse to do the one thing the famous story said they should. A willow that is truly recovering does not just get a little taller. It races for the sky because it is trying to get its growing tips above the height where a hungry elk can reach. These willows never made that run. They idled. After 4 years of total protection, the fenced willows sitting over normal ground had crawled to only about 106 centimeters, a little over 3 feet. And in the last year of that stretch, some of them had almost stopped growing at all. You could keep every elk in Montana away from these plants, and they still would not become trees. They just sat there, stunted, safe, and stuck. That should have ended the wolf story right there. It did not. Because the failure was the clue. Here is the question that cracked it open. If it was not the elk holding the willows down, what was? The team ran a second, sneakier version of the experiment. They did not just fence out elk. On some plots, they built fake beaver dams. Low structures across the little streams meant to do one specific thing: back up the water and lift the water table under the soil. Then they compared: fenced and dry, open and dammed, fenced and dammed, every combination. The willows, with their roots in raised, wet ground, took off. They pushed up to about 147 centimeters and kept climbing, gaining real height year after year. And here is the detail that flipped the whole thing over. On the plots with high water tables, the willows grew fast even when elk were still allowed to browse them. Wet feet mattered more than safety. The dam mattered more than the wolf. Now hold on, you might be thinking. Maybe those willows were just slow. Maybe a few more years of peace and quiet from the elk would have gotten them there anyway. It is a fair doubt, and the scientists had the same one. That is exactly why they added the water. If time and safety were enough, the fenced and dry plots should have caught up eventually. They did not. The plots without raised water stalled out low and stayed there, while the ones with wet roots kept pulling away. It was not patience the willows were missing. It was groundwater. So the real question was never really about elk at all. It was about water. And to understand where the water went, you have to meet the animal nobody was talking about. The beaver. Rewind again, past the wolves, past the elk. For thousands of years, the small streams of the northern range were not the deep, fast, cut-down channels you see today. They were slow, messy, and wet. Beavers had built dams across them, hundreds of little speed bumps that backed the water up into broad ponds and soaked the ground on either side. Think of the whole valley floor as a sponge held full by beaver engineering. Willows love that. Wet roots, slow water, mud to sprout in. Willows and beavers fed each other in a loop. The willows gave the beavers food and building material. The beavers gave the willows water. If you could stand in one of those old beaver meadows before any of this went wrong, it would not have looked majestic. It would have looked like a mess. Braided threads of shallow water, mud you could sink a boot in, dead sticks poking up, ponds stacked one above another like a staircase of puddles. Not pretty. But that mess was doing an enormous amount of work. Every dam was catching sediment and building soil. Every pond was a slow tank holding spring melt water and letting it out gently through the dry heat of late summer. So the streams still ran when other creeks went to dust. The ugliness was the function. Then people shot out the wolves, and the elk population swelled. Through the middle of the 20th century, those hungry elk hammered the willows down year after year. And when the willows got too short and too few, the beavers ran out of the tall stems they need to eat through winter and build with. So the beavers left. By the 1950s, they were gone from many of those small streams, gone for more than half a century. And that is when the real damage happened, quietly, underground. Without dams, nothing was slowing the water. The streams began to cut downward, knifing into their own beds, carving deeper and deeper trenches. Picture a slow drain opening in the bottom of that sponge. The water table dropped. The wet meadows dried out. The ground that willows needed turned from soaked to thirsty. The valley had lost its plumbing. And by the time anyone alive today walked up to those creeks, the damage looked like scenery. A clear stream running fast in a deep channel looks clean. It looks wild. It looks like a healthy mountain creek is supposed to look. Almost nobody remembered that it used to be a wide, sloppy, willow-choked beaver marsh. People were not looking at a river. They were looking at a wound that had healed crooked and calling it normal. This is the trap the experiment exposed, and it is brutal once you see it. To get tall willows back, you need a high water table. To get a high water table, you need beaver dams. To get beaver dams, you need beavers. And to get beavers, you need tall willows for them to eat and build with. Every door is locked from the inside. Willows need beavers. Beavers need willows. Take one out for long enough and the whole thing seizes up and stays stuck, even after the original problem is gone. Scientists have a cold name for a system frozen like this: an alternative stable state. It means the land found a new normal, a broken one, and it will sit there forever unless something forces it out. And here is the part that should make the famous video uncomfortable. Wolves cannot force it out. A wolf can scare an elk. A wolf can thin a herd. What a wolf cannot do is raise a water table. It cannot rebuild a dam. It cannot undo 50 years of a creek cutting into the dirt. The predator at the top of the chain was never holding the load-bearing piece. The animal that was actually engineering the river sat in the middle, with orange teeth and a flat tail, and it had walked off the job decades before the first wolf crate was ever opened. So did the wolves do nothing? No. That would be its own kind of myth. The elk really did decline after the wolves came back. The northern range herd fell from around 19,000 animals at its peak to as few as 6,000, and in some counts even lower, down into the 3,000 and 4,000s. That is real. And in the places where the willows happened to still have decent water, less browsing did help them climb. But here is the honest part. The tidy version skips. That elk crash had many authors. Grizzly bears, whose numbers were climbing, were killing elk calves. A growing bison herd was competing for the same grass. There were years of drought, and human hunters, just outside the park boundary, were taking large numbers of prime breeding females every winter. Pull all of that apart, and the wolf is one hand among several on the same rope. Blaming or crediting the wolf for everything was always too simple. The evidence for the deeper story kept stacking up. In 2013, the Colorado State team published their willow and dam results in a major journal. Their conclusion was blunt: reduced browsing was not enough. Stream water and the beavers that control it were the thing that actually gated recovery. As Kristen Marshall put it, the real lesson was that we have to be careful not to remove predators in the first place, because you cannot simply staple the pieces back on later and expect the machine to run. Then, in 2024, the same lineage of research went further. A newer paper argued that the celebrated wolf-driven cascade should no longer be held up as proof, at least for the small streams of the northern range. The willows there had not staged the clean, valley-wide comeback the story promised. They had recovered in patches exactly where the water allowed, and stalled where the creeks had already cut too deep. And to be fair to the wolves, in the right spots the growth was not small. In some stretches of the northern range, researchers tracked willows whose crowns, the leafy tops, ballooned by well over 1,000% across roughly 2 decades. Where the water was there, less browsing turned scraggly survivors into real thickets full of birds. That is a genuine comeback. The catch is the phrase "where the water was there." That single condition decided almost everything, and it had nothing to do with wolves. Now, is everyone convinced? No. And that tension is part of what makes this real, not marketing. The scientists who first told the beautiful version have not backed down. William Ripple, one of the original authors, still defends the core idea that a real cascade ran from wolves through elk to willows. Confronted with the challenge, he said flatly that they reject the idea that there are fatal flaws in the work. Other researchers land in the middle, agreeing that some kind of cascade exists, while arguing about how strong it is and which predator deserves the credit. One of them has described the whole popular story as a genuine source of confusion. This is not a settled parable, it is a live argument between careful people. And the truest thing you can say is the least tidy. Wolves opened a door. Water decided how far anything could walk through it. For a lot of people, that was hard to hear. The wolf story had become a kind of gift, proof that we could undo our worst mistakes just by stepping back and letting a fierce animal do the rest. When the researchers started pulling the thread, some fans of the story felt let down, even deceived, as though someone had walked into a beautiful room and started pointing at the cracks. But the scientists were not trying to ruin anything. They were trying to get the fix right, because getting it wrong means pouring money and years into streams that will never respond. And then the story got stranger and better. Because that failed experiment, the one where fences alone did almost nothing, turned into a tool. If a fake beaver dam could unlock a stream that a returning predator could not, then maybe you did not have to wait around hoping real beavers wandered back. Maybe you could build the beaver's work yourself, cheaply, and jumpstart the loop. That is exactly what is happening now. Across the American West, restoration crews are hammering rows of wooden posts into dying streams and weaving in branches to make what they call beaver dam analogs. Low, leaky, deliberately crude little structures that mimic the missing engineer. They slow the water, they spread it sideways, they lift the water table, and once the mud and the willows come back, real beavers often move in on their own and take over the maintenance for free. In some places, the results show up within a single season. Post a leaky little dam across a trickle in spring, and by late summer there is a pond where there was bare gravel, green fringe where there was dust, and frogs and birds using water that simply was not there the year before. Ranchers who once saw beavers as pests that flooded a hayfield have started asking how to keep them around, because a stream that holds water into August is worth more than one that runs dry in July. Think about that. The mistake in Yellowstone, the willow that would not grow inside the fence, taught people how to fix creeks 1,000 miles away with a pile of sticks and posts that costs almost nothing compared to bulldozers and concrete. The trick was never force, it was leverage. Find the one locked door, the water table, and pop it open just enough for the old machinery to restart itself. But this is not magic, and the story is honest about where it stops. Beaver dam analogs only work where there is still water to catch, willow or seed sources nearby, a stream shape that can actually pond up, and landowners willing to let the water spread. Put them in the wrong place and they wash out or do nothing. And in Yellowstone itself, the pressure never fully lifted. A study in 2026 found that bison, whose numbers have grown, are now browsing the same willows the elk once hammered, chewing on the recovery from a new direction. The valley is not saved, it is negotiating, which brings us back to that scientist, kneeling in the gravel, holding a ruler against a willow that would not grow. That stunted little plant was not a failure of the wolves, it was a message. It was the valley trying to tell anyone who would measure instead of assume that the famous story had skipped a character. The elk were never the whole problem. The wolf was never the whole hero. Underneath the beautiful film about fear and predators and rivers bending back into shape, there was a plainer, older truth sitting in the mud. This land was built by a rodent that most people think of as a nuisance, and it broke when that rodent was starved out and left. No amount of top-down fear could rebuild what a bottom-up builder had abandoned. The wolves came home to Yellowstone and something genuinely changed. Give them that. But they did not reshape the rivers by themselves, and they could not have. The animal that actually shaped those rivers has a flat tail and orange teeth, and it had been gone for 50 years before the first wolf ever set foot back in the park. For 30 years, we have been thanking the predator at the top. The worker who actually held the water was the one we forgot we had fired. There are more stories like this, where the answer everyone celebrated turned out to be the wrong size, and the real fix was smaller, older, and hiding one rung down. Tell us which one we should dig into next.